Go.
Okay, in this video we're looking again at stoichiometry because we're going from one substance to another substance. But in this case, we're not just talking about grams. We're starting with grams, 2.5 grams of zinc, but now we're looking for volume of H2. It is at STP. Remember, STP is standard temperature and pressure. In this case, we've got grams and volume. We go back to our steps. We've got to balance our equation, and in this case it's not balanced yet. But if we put a 2 here as a coefficient, everything's balanced. So we read the problem, determine what's given and what we're trying to find. We have 2.5 grams of zinc, and we're trying to find the volume. Volume is measured in liters, so we're going to put question mark liters. So if we're looking at our mole ratio, we're only talking about the coefficients from zinc and the coefficients from hydrogen gas. We don't really care about the HCl or the ZnCl2. What conversions do we need? We need a conversion with grams, and we also need a conversion with the liters. So we're going to convert to and from moles because we have to use the mole ratio. So let's start with our given. 2.5 grams of zinc. I'm going to do the T-chart. We have to look on the periodic table to get from grams to moles. So if we look that up, it's 65.4 grams of zinc. That's equal to 1 mole of zinc. Now we're at zinc, but we've got to get to hydrogen. So we're going to use our coefficients. In this case, it's a 1-to-1. 1 mole of zinc is going to be on the bottom, so that they can cancel out. 1 mole of H2 on the top. Now that we're at moles, we've got to get from moles to liters. We know the conversion factor is that 1 mole is equal to 22.4 liters at STP. And in this case, we're at STP. So we can just put 1 mole H2 is 22.4 liters of H2. We can go back, make sure all of our units cancel out. That's why it's important to write grams, moles, moles, moles of H2 to moles of H2, and we're left with liters of H2. Multiply everything on the top, divide by the bottom, and we're going to get our final answer of 0.86 liters of H2. And that's your answer. Okay, we're going to move over to our second problem. And in this case, how many molecules of water are produced if 2.0 grams of sodium sulfate are produced in the reaction? So, we have our given right here. We're looking for molecules of water. Notice the word molecules. That's in that particles category. We look at our equation. We can write down, we have this given, 2.0 grams. We're trying to find this, molecules. Going through our steps, we have to balance our equation. So we're going to put a 2 here and a 2 here. And you can write everything out. We know our mole ratio is going to be with the 2 moles of HOH to the 1 mole of Na2SO4. We don't really need this. The only reason we needed this at the beginning, one, it's part of the reaction, and the other thing was to balance out our equation. So, start with your given. 2.0 grams, in this case, Na2SO4. You're going to have to find all of this on your periodic table. If you do that, you've got 2 of the NAs, and that's 2 times the 23.0. You have 1 sulfur times the 32.1. The oxygen is 4 times the 16.0. So that is 46.0, 32.1, and then 48.0. So if we add this all up, since I've already done it, we're going to get 142.1 grams. And that's our molar mass. So we're going to use that right here, 142.1 grams of Na2SO4. That's equal to 1 mole. Now we're getting from moles of Na2SO4 to what we're trying to find. Use your mole ratio to 2 moles of water. You can write it H2O or HOH. Now we're going from moles to the molecules. 1 mole is equal to 6.02 times 10 to the 23rd molecules of HOH. Again, that's Avogadro's number. We can cancel everything out. Grams to grams, moles to moles of Na2SO4, moles of HOH, moles of HOH, and we're left with molecules. Multiply everything on the top, divide by the bottom, and you should get 1.7 times 10 to the 22nd molecules of HOH or H2O. And that's it.